All right, guys. I hope the quiz went well for everyone. So today we're going to look at tutorial 3. But before we start with the tutorial work, just a bit of quick housekeeping. So the first thing I wanted to mention is all of last semester's tutorial videos have been posted on UTS Online. So if you go to additional resources, there should be a link that says tutorial playlist over here. And if you go to the tutorial playlist, you will see a list of all the tutorial videos, including the ones that I re-record, right? For example, tutorial 1 wasn't recorded last semester. So this semester's recording of tutorial 1 is up here. Also, there are a couple of videos right at the bottom called extras. So my plan is, instead of repeating all of this material again, which I think is since it's already up here in the videos, I think you guys will benefit more if I spend this time talking more about practical issues that could help you with your project. And also go through questions that you have regarding some of the tutorials. And I think it'll give me an opportunity to go deeper into some of the areas as well. And I will be recording these sessions again, and all of that will be added onto this playlist, right? So for example, if there is any new material that I record regarding tutorial 2, I'll add it here next to the rest of the tutorial 2 content, right? But I think this will give us an opportunity to explore some of the topics a little more deeper. I've always felt that there's not enough time in this course to properly explain some of the ideas and some of the concepts, and also some of the practical aspects that might help you in your projects. So I think it'll, instead of repeating the material, which you can already find here, what I thought I'll do during these tutorial sessions is discuss the tutorial more deeply, and then also talk about a couple of like extra information that wasn't discussed in other semesters, but from my experience working with some of the students working on their projects, I think might be helpful for all of you, right? And those extra material will appear at the bottom of the playlist called with this title called extras onto it, right? So every week I would be then expecting all of you to sort of watch these videos that kind of correspond to that week's tutorial, right? And that, I mean, most of them are quite short, like maybe half an hour to 1 hour max. And you can even like listen to them in like twice the speed. And during 1 week you can finish them off very quickly, and then if you have any more questions, we can then discuss them during the class, right? So we are currently in tutorial 3, right? So I've in class covered tutorial 2 up to question 2. So question 3, and this is the next part that I want to discuss with you guys. So question 3 has to do with working with actual sensors, right? So there are 3 sensors that we would like for you to have like a hands-on experience with, right? One is cameras, right? And second, RGBD sensors, right? And then laser sensors, right? So usually before the whole quarantine happened, what we would do is we would hand out actual cameras, actual RGBD sensors, and let you guys kind of play around with them. So last semester we didn't do that because it was like the beginning of like the lockdown, and university was for all practical purposes closed down. But now we kind of have the opportunity to have a couple of drop-in sessions. But I'm still quite worried about them because we are on the brink of a possible second wave and things like that. So what I was thinking was, what I'll do tomorrow is I'll set up a quick poll on UTS Online. I'll send the link around to everyone, and I want to get feedback from all of you to see if we can arrange one class where we can actually play around with these sensors. So there is one small issue with this. We are only allowed to have like 12 people per class in the lab at a time. So I just want to make this clear. This is completely optional. You don't have to do this. This is only if you want to actually physically play around with some of these sensors. So what I'll do is I'll put up a poll asking how many people would be willing to actually drop in, and then based on the number, what I can do is arrange a couple of sessions during the regular tutorial time, where you can drop in and play around with a camera, RGBD sensor, and a laser sensor, right? So these three sensors, playing around with these three sensors correspond to tutorial 2, question number 3, right? Which is the question we didn't do last week, right? And the RGBD sensor, I believe, is tut 3, question 2, and then tut 4, question 7, right? So these are the 3 questions that I hope to cover all in one day, right? So I'm planning on doing this sometime maybe in week 5, right? So it will be a one single day where you get to do these 3 questions: tut 2, question 3, tut 3, question 2, and tutorial 4, question 7, right? So during the up until week 5, I will skip these questions, right, and just do the rest of the questions. So these 3 particular questions have to do with actually physically playing around with these cameras and sensors, right? So in case there are not many so I'll be doing this in the lab with everyone, but I'll also record it, right, and I'll be putting it up online so everyone can watch it, especially those who don't want to put themselves at risk by coming to the lab. So like I said, this is going to be completely optional. In addition to that, what I will do is I will record ROS bags that have the sensor information, so you can actually play them back and play around with the sensor information as if the data is coming from a real sensor, right? So I will explain what a ROS bag is today, right? And if what I just said sounded like complete mumbo jumbo, it will make sense once I explain what a ROS bag is, right? But my point is, I will make sure there is an option to do these questions for those of you who don't want to actually attend this drop-in session in the lab, right? So I will set up this poll tomorrow, and I will send it around via email and with a link to UTS Online, and then all of you can mention whether you want to join or not, so I can get a rough idea of the numbers and then plan on how to kind of arrange this class. Okay, so I hope that makes sense, and just have a look at this playlist. That's the other thing I wanted to tell you guys about. And so for next week class, if you can watch week 3 and week 4, what we can do is then discuss these questions in greater detail in class, right? So today since I'm mentioning this to you today, what I'll do is I'll do tutorial 3 today, right? Only question 1, because question 2 is regarding this part, which, like I mentioned, I'll do in week 5, right? So what I thought is I will do question 1, and I will also do a bit of a deep dive into ROS, right? So today I'll talk a little bit about ROS, right? The robot operating system. So again, like I mentioned before, since we have the benefit of these recordings, I can go deep into topics that I couldn't do in previous semesters, which I think will be beneficial for all of you. So I hope that makes sense. if you want me to do the tutorials, like every single question in great detail, and basically repeat the material that I did before, just let me know. But I think this makes more sense because the material is already online and it gives you an opportunity to kind of dive deeper into some of the topics. So I hope that makes sense. Is that okay with you guys?
I got a question, Manny.
Yeah.
I have gone through the material for question 3, tutorial 2, right? It said I have to set up ROS,
Yes.
right? The robotic operating system.
Yes.
And if I'm using VR RAM that provided by university, do I still have to set it up? Because I've seen this.
Okay, so I kind of covered this the first class that we had. You are completely free to use a VRware,
Yeah,
VMware, right? A virtual machine.
yeah, VMware, yeah.
Yeah, you're completely free to use a VMware. But I would suggest setting up a dual boot system with Ubuntu because it will be faster.
Yeah, I
And
tried, but I think my Wi-Fi module is something wrong with my hardware, with my Wi-Fi. I tried to download I tried to set up the what's that called? Internet driver. Because when we do the installation, it's not included the internet drive. So
that's
the
usually
Bluetooth works,
usually
but the Wi-Fi doesn't work. So it makes me has to use the VRware. Yeah.
Okay, so I think there's a couple of issues there that you need to debug. That shouldn't be the case, but like until I get a hand on say your system, I can't really say what's going wrong there. But typically that is not a problem. And if you are missing some drivers, you can always set them up. But if you are having trouble and you don't want to go to through the trouble of debugging that issue, you're free to use a VMware. But you have been forewarned. It's just going to be a bit of a pain in the
Yeah,
ass.
I know. I try to fix it up. Yeah.
Yeah.
So
So
if
it's
we're
completely up
using
to you.
VMware, so the ROS is already installed in the Ubuntu, right?
I don't know. Depends on the VMware image that you're using. So um, if you have one
Okay.
with ROS already installed, then yeah, great.
So we will go to do ROS on week 5, as you mentioned, right?
No, so we're starting with ROS today. So I'm going to explain what ROS is, and I suggest you start getting familiar with ROS now because your projects will be starting in week 4, right?
Yep.
And if you start learning ROS now, by the time you start your projects, things will get much more easier, right? Because
Okay.
there's a bit of a learning curve associated with it.
Okay.
Yeah, what I mentioned about week 5 is basically the hands-on, like actually physically playing around with sensors. So you don't actually need to do that to learn ROS. You can play around without actual sensors as well.
Okay.
Yeah, so that's what I meant by week 5. But you should start learning ROS as of like
Okay.
this week. Right, so
Okay.
I'll give you guys a basic introduction to ROS today, and that's my intention for today. Instead of spending too much time on the tutorial itself, because the full explanation of the tutorials are also in these videos. Actually, for today, I will re-explain everything. Like I will actually do the full question, hopefully. But from next week onwards, I would expect you to watch these videos. So, like for next week, watch tutorial 4, the tutorial 4 videos, and then we can discuss them in class, right? Yeah, from next week onwards. So don't worry about, because it's kind of unfair for me to ask you to have watched today's video when I just informed you that you should watch these videos, right? So yeah, so but a chunk of today I just want to spend on ROS. So because I'm pretty sure a lot of you have a lot of questions regarding ROS and what it is, and it's just a completely new thing for a lot of you. So I thought I'd just spend some time talking about it today, right? So let's jump right into it, right? So if I'm kind of going really fast or something like that, just let me know, and I'll try to slow down. But this is supposed to be just a brief introduction for some of the important concepts. And if you can grasp these concepts, ROS becomes much more easier. It becomes more of like a coding problem rather than understanding the concepts, right? So let's begin. So could someone tell me what ROS stands for? So yeah, ROS. ROS stands for robotic. Oops, operating system. Sorry, robot operating system, right? So all of you are aware of operating systems. So we have operating systems like Linux, we have operating systems like Windows, and so on, Android, whatever, right? But robot operating system, or ROS, is usually considered a meta operating system, right? So what you mean by meta operating system is it kind of sits on top of regular operating systems. So ROS can actually work on top of Windows. It can work on top of Linux, right? Android, and all sorts of operating systems, right? And the idea behind ROS is to make it easier to do robotics applications by making it easier to talk between these different operating systems, right? And not just different operating systems, but also different hardware, right? So for example, in my PhD project, I'm working with a robot that is running 3 different computers, right? This is just an example of the power of ROS, right? 3 different computers. One is a Jetson, right, which is made by NVIDIA, right? So it's called an NVIDIA Jetson. It has a ARM processor, right? And then I have another computer which is a Intel Upward, right, which runs Intel processor, right? And both of these are running Ubuntu, right? And actually the NVIDIA is running Ubuntu 16.04, this is running 18.04, right? And then I have another Android tablet which I use to get cellular GPS, which is running Android, right? So these are like different operating systems. So, and for example, if I wanted to, I could connect a Windows computer to this as well, right? So we have all these different operating systems, different processor architectures, right? And basically all sorts of different computers working together in one, and ROS enables me to network between them and talk to each other very easily, right? And I have no idea how I would have accomplished this without using ROS. ROS really makes your life much more easier. And the great thing is, like, it's not just these computers, but there's like different sensors, right? I have a couple of cameras connected to this computer, right? I have GPS modules connected to this. I have encoder sensors connected to this, and all sorts of stuff, right? So all of them are seamlessly talking to each other because of because of ROS, right? So again, just to recap, it's a meta operating system that can sit on top of other operating systems and make communication between different systems and different sensors much more easier, so that you can focus on more complicated things rather than like connecting the hardware and talking. So it just provides one framework that allows you to makes like robotics applications much more easier, right? So ROS came around, I think 2010ish, if I'm not mistaken, and it was created by a company called Willow Garage, which was a famous robotics company that got bought out by Google. So it's completely open source and completely free, which is amazing. And it's really helped, especially in academia, in universities and learning environments, helped a lot of people really progress the field of robotics because of this, right? So we don't have to spend time, like writing drivers to access different sensors or like networking computers anymore, because ROS provides this like common framework to do everything, right? And it's completely free and it's completely open source, which is great. right? So that's just a brief introduction of what ROS is. Now let's talk about some important concepts, right? By the way, stop me at any time, at any moment, if what I'm saying is like if I'm going too fast, right? So important concepts in ROS, right? So there are a few things I just list out here, right? First is the concept of nodes, then the ROS master, topics, subscribers, and publishers, right? What else? And messages, right? So there are these like 5 things that if you understand these 5 things, it should be a bit more easier for you to kind of code in ROS, right? So usually the software that you build with ROS, you can either use C++ or Python, right? Or even it has a wrapper for MATLAB, which should make things easier. Again, it's really great because it has these what you would call a wrapper, which allows you to write in other different languages, right? So you have a MATLAB, you even have a Java wrapper, you have a C# wrapper if you want, right? But mostly what is used, I would say, are these two, and maybe the MATLAB version, a MATLAB library, right? So you can write any of these ROS programs using any of these languages, right? Anyway, back to this, right? So there are these 5 concepts. So I'm going to go through each of these 5 concepts and try really hard to kind of understand these concepts, because these core concepts will help you when you're learning ROS more deeply. So I'm just going to give a very brief introduction to these, right? And if you can see the big picture and how all of these kind of connect with each other, then it will make your job of learning ROS much more easier, right? So first let's talk about nodes, right? So I'm just going to discuss all of this and then come back to this list and see, and then you can see if you actually understood it or not, right? So first let's talk about nodes, right? Like what's a ROS node and so on, right? So if you take a typical robot, right? You have a robot, and let's say it has some sort of arm, right, that you can control, and it also has a camera attached to it, right? And then it's got like motors here for the wheels, right, to control the wheels, and then it's got some sort of central computer that's controlling everything, right, which I'll draw here, right? So this is like some sort of computer controlling all of these different things, right? So ROS, one of the main principles of ROS is modularity, right? You try to create everything as modules, right? So for example, this arm, like everything that's related to this arm will be created in a different module, right? Everything related to these wheels you can kind of package in a different module. So this is module 1, this is module 2, right? And this is, say, module 3, right? So the advantage of modularizing your design is that, for example, if I use the same camera in a completely different application, right? If I use it, say, in a drone, for example, right? So if I had a drone, and let's say there's a drone, and I stick this same camera on top of it, right? Then I can use the same module that I designed that accesses this camera information. I can use that same module here, right? Which is what's great about modularizing your design, right? So think of it as different things you can plug in, like different modules you can plug in and use, right? So usually these modules are designed, let's say, by the the like robotics community. You can make your own module, right? And it's independent of all these other modules, right? So this module, say module 3, which handles the camera, will be, for example, providing camera information. It will be accessing this camera and spitting out camera images, right? So that we can kind of process it, right? And that action of spitting out camera images from a camera has nothing to do with this underlying robot, right? It just has to do with this sensor. So you can kind of modularize it and separate it out from everything else. And then the great thing you can do is you can just upload this module on the internet, right? And then anyone who buys this camera can download this module and access the information from that camera very easily, right? And that's basically how the open source community runs right now, right? And these modules are loosely, you can call it a ROS node, right? Right. So, for example, yeah, for a camera, you could have a separate ROS node for the controlling the arm and the motors. You could have a separate ROS node. For different hardware, you can have different ROS nodes, right? So ROS nodes help you kind of modularize your system, right? And kind of a better definition of what a ROS node is it's kind of like it's an executable file, right? It's an executable file, right? But it's more than just these modules. You can do so much in a ROS node, right? You can, if you want, access these camera information, and you can process them if you want, all in this single ROS node, right? Like, for example, if you don't want to have like a modular system like this, you want all of them in like one single big, instead of having modules, if you want them all in one single kind of blob, you can design a ROS node to do that as well, right? But the beauty of having ROS nodes is you can break up this problem into smaller nodes, right? And that's really the use of it. But it doesn't mean that you always have to do that. If you want to, you can kind of group everything together and write one single ROS node that does everything, that takes the camera information, that controls your arm, and then controls the motors, right? So really it's a executable block, right? Executable block that can read or access sensor information, right? It can process sensor information, or it can even publish that sensor information out, right? So there's so many things you can do with a ROS node, right? But the concept behind a ROS node is that it enables modularity, because then you can create separate nodes for these different things, and then you can share them with the community, you can share them with each other, right? You can just put it up on your GitHub page, and you created an open source kind of ROS node, right? So it's kind of like a program essentially, right? It's a program, right? A piece of software, but in the ROS world, it's called a ROS node, right? And typically you would write it, like I mentioned before, using C++ or Python, right? And it enables this really great quality of modularity, right? Which is a nice way of designing a system, right? But like I mentioned before, it's not essential that you create modules. It's up to you. You can just like chuck it all together into one single module, for example. Everything is up to you. You get to write this node, right? So it's really up to you and how you design this, right? So that is a quick introduction of a ROS node. Any questions before we move forward? So we just talked about ROS nodes. Yeah, is this am I making sense so far, or am I going over everyone's heads? any feedback? Are we good to keep going?
Yeah, all good so far, mate.
Okay, thanks. Hold on, let me just take that. Yeah, sorry, I wasn't looking at the chat. I need to access it. Right. Okay, cool. So that's a concept behind ROS nodes. So let's just understand how a typical system would be built, right? So if we take our generic robot again with the arm, the computer, the motors, and the camera, right? What would be the ROS nodes that we would have, right? We would have one ROS node for the camera, right? We would have another ROS node for the arm. By the way, this is a very simplified kind of depiction of what would actually happen, right? And then you have another node for the wheel motors, right? And then if you want to, you can separate out another node, kind of jot out here, node 4 for all the processing, right? So that will be maybe in this computer over here, right? So apologies for the spelling mistakes. Yeah, so so the job of node 1 would be to access the camera information. So you'll have this hardware, right? And it will be basically it's a camera, and we learned about how cameras turn light into images, and then if you want to access those images in your computer, you will need typically what we call a driver software, right? So I hope everyone's familiar with what a driver is. So a driver is a piece of software that helps you talk to hardware, right? So you would typically, your computer would have a driver for communicating with your monitor, with your speakers, with your graphic, your GPU and all sorts of stuff, right? So any piece of software that kind of talks to different hardware components is called a driver. So this node 1 will act as a driver that talks to your camera, right, and gets information from your camera, right? So obviously we would want these nodes to kind of communicate with each other, right? So there has to be some sort of communication between all these nodes so that we can kind of process them, right? So typically we would want, for example, this node 4 processing unit to take a camera image, then kind of use that camera image to say detect let's say there's some sort of object over here. So it takes a camera image, it processes the camera image, detects this object, and then tells the arm to go pick it up. But if the arm is too far away, it will activate these motors, and then it will move forward so that the arm can go pick up this object, right? So then we would have this camera image needs to talk to this processing unit, and then the processing unit, after recognizing this object, will tell the arm to go pick it up and tell the wheels to kind of move the robot towards the object, right? So that's basically how we would want everything to kind of talk to each other, right? So the cool thing is ROS provides an easy framework to talk for all these different nodes to talk to each other, right? So whatever information it gets, you can bundle that information and put it out into this network, right? And we call that process publishing, right? So you can publish information into kind of a ROS network, right? And anyone can listen to it, right? So this node, if it wants to, can listen to this published information. This node can listen to it, this node can listen to it. But if you want to listen to it, that node has to subscribe to that information, right? So that node has to kind of subscribe to that particular information that's being published, right? So for example, if it's only the processing unit who wants to listen to this camera information, it has to subscribe to this information. So the camera will just keep publishing out into like the ether. It will just keep publishing it. Any of these different nodes can come and listen to it and can come and subscribe to it, right? And just to show you what the possibilities of this are, for example, if this had like a Wi-Fi connection and you had a laptop over here, right, and you're on the same network, your laptop could also subscribe to this information if it wants, so if it has ROS on it, right? So it doesn't really have to only be on physically on this robot, right? Anything that is connected to a network, right, either through Wi-Fi, through USB cables, through like LAN cables or Ethernet cables or whatever, right? Any sort of system that's running ROS who is connected onto that same network can listen to this published information and subscribe to it if they want to, right? So you would then, for example, if you had an external laptop here, you would create a node here that is listening to that information as well if you want to listen to that information, right? For example, if you want to display the camera information that's coming here, you can subscribe to that camera information and kind of display it on your laptop if you want to, right? So this camera node will be constantly publishing information, and whoever wants to listen to that information has to subscribe to that information, right? So every node can have what we call publishers. So in this node, for example, you'll have a publisher, right, which is kind of like a function that does the publishing, right? And here you can have a subscriber, right, which is a function that listens, right? So whenever you write these functions, a subscriber or publisher, you need to mention who you want to subscribe to, right? So how do you know who do you want to subscribe to? Whenever you're publishing, you publish under something called a topic, right? So because there could be multiple sources publishing stuff, right? For example, the ARM could be publishing information as well. Like for example, the ARM could be publishing information about, say, maybe these joint angles or something like that, right? So it could be publishing information as well, right? So when you're subscribing, you need some sort of way to distinguish between the camera node information that's being published and the ARM's information, right? So how you kind of distinguish them is through topics, right? So this information will be bundled into something called a topic. So this will be camera topic. So you'll give a name to the information you're publishing, and this could be, say, the ARM topic, right? So I will show you guys in a bit what these topics really look like, but it's just a name you give the information that you're publishing, right? So if it's a camera topic, so if you're writing this node, you get to when you're writing a publisher, you get to decide what this name is, right? You can set it to whatever you want, right? You can set it to, like I said, the name camera topic, or you can I don't know, something completely random, like, I don't know, cookies, if you want to, right? I think I'm craving for some cookies, which is probably why it popped into my head. But you can call it whatever you want, right? You just give it a name so that people who are listening to it can say, okay, I want to subscribe to this topic called cookies, right? And then I'll be listening to this particular information that's being published by this node, right? Now, this is a very simplistic view. In reality, one of these nodes could have multiple information published, so it can have multiple topics being published, and a single node can publish and subscribe to information at the same time as well, right? So in this simplistic example, this node is only publishing camera information, and this node 4 is subscribing to that camera information. But in reality, for example, this node will then have to publish information to these wheels and the arms so that you can control them, right? So this will be publishing information to these nodes, right, in its own topics, right? So it will say publish a topic that says move arm or something like that, right? And here it will topic that says maybe the wheel speeds or something like that, right? So in reality, one of these nodes can subscribe and publish any number of topics, right? But again, these nodes are pieces of software, they're executable softwares that you get to write. So you can decide what you're publishing, what you're subscribing to, and all that stuff, right? And what the names of those topics are, right? Okay, so that covers the topics and subscribers and publishers, right? So we talked about nodes, we talked about topics and subscribing and publishing to those topics, right? So what the ROS master is, right, is basically you need someone to kind of oversee this whole process, right? So and also provide a certain level of security, right? For example, I told you, if you have a laptop like this and you connect into this system, you can then listen to everything that's going on here and then also publish information to it or subscribe from this robot, right? Which poses a potential security threat, right? And for example, if this computer is connected to the internet, right, someone from halfway across the world could have access to your robot, for example, right? And in addition to that, there's a lot of networking that's going on here, and all of that has to be kind of managed, and that's what the ROS master does, right? So the ROS master kind of manages this entire process, provides certain levels of security and all sorts of stuff, right? And it basically handles the networking process that's kind of happening underneath the hood of this whole process, right? So usually you would start this ROS master by a command called rosco, which we'll see in a bit, right? But yeah, that's basically what the ROS master does, right? So that's a ROS master covered. And now the final concept that you kind of need to be aware of are messages, right? So now I told you that you can have different topic names, right? That you get to kind of define what these names are, right? That kind of publish this information. But underneath these ROS topics, the information you're publishing has to have some sort of data structure, right? For example, if it's a camera image information, right? So for example, if it's camera images that you're publishing, right? We already learned what that looks like. So we learned that a camera image is just a matrix, right? With rows and columns, right? So there is a particular data structure associated with camera images. And then if you want to just say publish a word, right? Just let's say you want to keep publishing that the system is working okay, and you need to just publish the word okay, so that someone else can listen and know that the system is okay, right? So in that case, you'll be publishing a string, right? So you have these different data types and data structures that are associated with the kind of information you're passing around amongst these nodes, right? So each of these topics will have a associated message type, right? So there are a couple of standard formats, right? There are a couple of standard message type formats that you can use to transfer information, right? So if it's an image, there is a message type called sensor messages. Yeah, so I'll just Google it and show you guys, right? So if I Google sensor messages ROS RGB image, right, you see that you get in the documentation what the message type is, right? So you have sensor messages /image. This is a message type, right? that kind of bundles all your information that you're publishing, right? And if you look at the definition of this message, you can see it first as a header, right? Then it has a height and width value, right, which is tells you the height of the image, width of the image, right? It will tell you the encoding of the pixels, like uint 8 or uint 16 or whatever, right? And then it will also have the data, as you can see, right? So this is, if you want to publish an image, you would use this definition, right? This type of message, right? So your topic, say cookies, could have, if you want to send images using this topic, you would have to send image messages, right, in this format. So it's kind of like how do you bundle different types of data so that you can transfer it with each other, right? So this is an image type. Let's look at something else. Let's say sensor messages, point clouds, for example, right? So you'll have a different definition of those point cloud images, right? So you can see here that you'll have the data. Looks kind of similar, but if you compare the two, for example, this line is not here in the image data, right? So each of these topics have to be of a particular type, right? So this cookies topic can only, if you define it to transfer image data, will only have data of the type image, right? So it can only then transfer image information, right? It can't transfer, say, information from a laser sensor, right? Then you'll have to change the message type, right? So it's kind of like it's basically a format, right? So you have different message types, and when you're writing these topics, you need to specify which image type, which message type that you want to kind of communicate to other nodes, right? So a typical message, right? So you can look at, so you have different types of messages, but a typical message, there are a couple of common things, right? One thing is the header, right? So I'll just call this common elements in messages, right? So the first thing is a header. So the header carries information like the timestamp, right? It will also carry information like which frame the information is coming in, and like which sequence number the information is, right? So what I mean by frame is, for example, when you're getting image information, everything will be like, all your image information will be coming relative to this camera's reference frame, right? And then your wheels will be turning relative to some other transformation frame, right? And your arm will be like, all the measurements in your arm will be relative to some sort of coordinate frame set at this arm, right? So your header information will tell you in which frame you're getting the information in. So then you can transform that information from, say, if I'm getting that information relative to the camera, let's say, okay, I'll just do a simple example. Let's say this camera observes this box, right? So this camera observes this box, and it says that the box is 5 meters away from the camera, right? It's 5 meters away from the camera, but that doesn't mean it's 5 meters away from the arm, right? So it could be like 2 centimeters away from the arm, right? So when you say it's 5 meters away from the camera, you need to transform that information to what it means relative to the arm's coordinate frame, right? So there are these different frames of reference in your robot that usually you have to be aware of, right? So when you're publishing a message, this header information tells you which frame you're looking at as well, and the timestamp, at which moment in time is that message being received. And usually there is also a sequence, like, for example, I guess that's self-evident. I mean, you'll be getting, say, a camera information in a particular sequence, so you'll have a sequence number associated with it, right? So this typical header information is common to most message types, right? And then you'll have the data, right? So the data will depend on which type of information you're trying to transfer. Like if it's an image, this data will look different. If it's a laser, it will look different. If it's any other type of information, it will look different, right? So these messages kind of bundle the information into these bite-sized chunks, which then your topic kind of has so your topic is kind of like an address to look at, right? And that underneath that topic will be multiple messages being published according to sequencing time, right? So, and that message will be kind of a bundle of information about the information that's available at a given moment, right? So that's so that really covers the fifth concept in ROS that we need to be aware of, right? So let's put all these ideas together, and we'll try to kind of understand this a bit more, like go through these concepts a bit more with some concrete data. And to do that, we'll look at today's tutorial, which is tutorial 3, and we will kind of go through some of these questions and kind of try and understand all of these concepts a little bit more deeply with a concrete example. So any questions so far? Okay, cool. So I assume everyone's okay. Okay, so where to now is the next question. Like, what do you, armed with all this information, what do you do, right? So the first thing you need to do this week is go to ROS wiki, right? And you get a bunch of tutorials. Okay, so there are beginner level tutorials that teach you how to set up ROS, how to access these different nodes, how to understand topics, all sorts of stuff. How to write a simple publisher and a subscriber. There is how to write it in C++ or in Python, so you can pick whichever you're comfortable with. If you're a complete beginner to coding, I suggest going with Python. If you have some experience and want to learn C++, you can go with C++. But I suggest going through these beginner level tutorials. There's 21 of them. And then there's intermediate level ones as well. But I think for now the beginner level tutorials should help you quickly come up to speed with some of the basic concepts. So there's also like plenty of YouTube videos and stuff that help you learn ROS, but I think this official ROS documentation tutorials are quite good. They just do things very simply and cover most of the basic concepts, right? So it's a good starting point. So one more thing that we need to talk about, before we kind of move on to today's tutorial, and that's what the heck is a ROS bag? Right, so I mentioned what a ROS bag is before as well at the start of this class. So what is a ROS bag, right? So a ROS bag is basically okay, so if you're running your robot, right, and you have all these ROS nodes running, right, what you can do is you can record all that data in real time, right? And you record that data into something called a ROS bag, right? So this ROS bag, basically, as you're recording data, like for example, if you're getting a camera image at 5 seconds, it will store that camera image in sequential order, right? So if you get if you get 10 images, right, one at 1 second, the other at 2 seconds, 3 seconds, 4 seconds, and so on, right? It will store that data in a nice little package called a ROS bag, which will say, okay, at 1 second I got this camera image, at 2 second I got this camera image, right, and so on. And then, for example, in the middle of that, let's say you're also getting information about the speed of your motors, right? Then that information will, all of that will kind of sequentially be recorded in this ROS bag, right? Which is quite awesome, right? Because what that means is you don't have to, like, especially when you're doing experiments, you don't have to repeat that experiment over and over again. You can just record the data, and then you can play back this data, right? You can play back this data in real time, right? You can play back the data in real time, so it plays it back sequentially. So it's kind of like recording a video, for example, right? So you can watch it again, and what that means is, like, for example, like, take for example my project, right? So my project involves, I have a robot that every time I have to do experiments, I have to take it outdoors, right? And then I have to set up a whole bunch of stuff, and then it's just a pain to, like, take it outdoors and set it up, and if it's raining or something, I can't do my experiment, right? And what I can do instead is I can just do the experiment on one single day, record a ROS bag, and then I can use that data over and over again in my experiments, right? Then I don't have to keep doing my experiments physically, right? And the great thing is, when I'm playing back the ROS bag, when I play it, right? When I play back the ROS bag, from ROS's perspective, it doesn't know whether it's actually coming from a real system or a ROS bag, right? So if you have the real system, so this is the real system. So say, okay, you have the real system, and then you have a ROS bag, which is a pre-recorded kind of sample of your system, right? So if you're running the real system, you'll have camera images being published and so on, and then you can be writing some sort of code to process those camera images and so on, right? So if you're running the real system, you can do that and test it. But if you have a ROS bag, which is like pre-recorded, your code wouldn't know the difference between this real system and the ROS bag, because from the code's perspective, from ROS's perspective, right? From ROS's perspective, you're still seeing the same topics being published. So, like, for example, if there's a topic called cookies being published in your real system, and then you record it, it will still be publishing the same topic as if it's being played in real time. So from ROS's perspective, it doesn't matter whether you're playing it from a ROS bag or a real system, right? Because it's just kind of like a recorded version of the real system, right? So then you can write new pieces of code that listens to this information and publishes back to that information and so on, right? And then test your code, which really frees you up and gives you a lot of options, right? And especially makes sense during this quarantine time, where you might not be able to do experiments every day. So then what you could do is quickly record a data set and then go home and then play the data set and pretend like it's coming from a real system. Because for all practical purposes, from ROS's perspective, the information is being published the same way it would be if a real system is publishing that information, right? And you can kind of play this ROS bag and see it being published, right? So let's actually jump into the tutorial and play around with the ROS bag. So before we do that, coming back to what I mentioned at the start of the class, right? Which was, I'll be playing around with these 3 sensors on week 5, right? But as I mentioned, I'll be only doing this with people who are willing to come to the class, and it's completely optional. So for those of you who don't want to take the risk of dropping into the lab, I will provide ROS bags of a RGBD sensor, a laser sensor, and a camera sensor, right? So that you can kind of access these ROS bags and pretend like you're actually playing around with sensors, because these ROS bags will, the only thing that will be missing is the actual sensor, but the information will be present in this ROS bag, right? As if you had just gotten it from an actual sensor. So I hope that kind of makes sense. But yeah, we'll actually use a ROS bag and kind of see how what it really looks like, right? So if you go to today's tutorial, why is my mouse not working? Yeah, sorry about that. Okay, so if you go to week 3 and look at the tutorial section, there should be a ROS bag, right? So you can see here there's a file called tutorial_rgbd.bag, right? So the extension of a bag file is .bag, right? So you can see that the file is about 2.4 GB, which would probably take a while for most of you to download, and we only have like 20 minutes. So what I suggest is just watch the video for now, as in watch me play around with it, and then once the class is over, maybe download this and try it out for yourselves, right? So I've already have the file on my computer. You can see it here. It says tutorial_rgbd.bag. So this is a ROS bag of data collected from a RGBD sensor, a Kinect sensor to be precise, right? And it has information stored from a Kinect sensor, and we'll play back this ROS bag and see how we can kind of access this information in our terminal as well as on MATLAB, right? So if you look at our terminal, right, what you would need to do is go into the folder that has the ROS bag. So I have a folder called ROS bags, and if I say ls, you can see that I have this bag that I want to play, right? So remember I said that you need a ROS master that controls everything. So you need to start that by typing this command ROS core, right? So that creates a ROS master, right? It's kind of like a server that sets up your network to communicate with, right? So you can see here that you started a ROS master, right? So now what I'm going to do is, the first thing I'm going to show you a couple of commands that might be helpful. So you can write these commands down. The first command is, if you want to see what a ROS bag has inside of it, you can type ROSbag info, right? And then give the name of the ROS bag. So the ROS bag name was tutorial_rgbd.bag. So if I press enter, you can see here that I get a whole bunch of information about the ROS bag, right? So so this looks complicated, but it really isn't, right? If you just read through it, you can see that it tells you the start time. So you can see this bag was recorded on October 15, 2017 at 1:10 or 1:09, and it ended at 1:10, right? So this ROS bag was actually recorded by the guy who was running this tutorial class before I was, yeah, this was back in 2017, right? So this is a quite old ROS bag, right? And then it tells you the different message types, right? So remember I told you you can have different messages. So you can see that there are image messages, point cloud messages, information about camera, and a whole bunch of other stuff over here, right? And then these are the topics that have been published. So you can see there's close to about 100 topics that were published, right? So by the way, this is from a single node, right? So the Kinect is launched by a single node, I think, right? I'm not sure actually. There could be a few multiple nodes in the Kinect running, right? But point is, there's a whole bunch of topics that have been published, and here you can see how many messages per topic have been published, and then the message type as well, right? So for example, if you take this topic, so there's a topic called camera depth image, right? and there are 44 images that have been published, 44 messages that have been published, and this is the message type, right? Sensor messages underscore image, which is the definition we looked at just a few minutes ago, right? This. So it's this type of message. So you know when you see this message type that it's a camera image, right? Right, and this camera image has the depth information, right? And then you can see there's a whole bunch of messages like that that give you all sorts of information. Let's just scroll down and we can see that there is a RGB image as well, right? So just a bit of theory before we look into this about depth cameras. So today you probably learned about depth cameras, right? So there are different ways of getting depth information. There are stereo cameras, structured light, time of flight sensors, right? And the whole idea behind the depth image is, so if you have a depth image, unlike a RGB image, right, the matrix has depth values in them, right? Not intensity values, right? So for example, it will tell you how far this pixel is. Basically the Z component, remember if we drew the pinhole camera model, this distance, the Z distance, right, is what is mentioned in these depth images, right? So they won't really tell you about color or anything like that, but they will tell you about the depth, like how far away in this Z direction is this particular pixel, right? So that's what a depth image is. And then you have our regular RGB images, right, which we learned last week, right? So that's the difference between depth images and RGB images. So you can see that here you have the RGB image information, and there are 747 images, and then here you can see this is the depth information, and you have 44 messages, right? So that's what's contained in this ROS bag. So if you want to play this ROS bag, right, it's simply you just say ROS bag play, right, and then you type in the name of the ROS bag, right, and if you click this, you can see that it's being played, right? So from ROS's perspective now, it's as if there's an actual RGBD sensor here, right, and we've traveled back in time to 2017, and we are accessing information from that sensor, right? But all we're doing is actually just playing that ROS bag, right? So you can see that there are 60 seconds worth of information, and it's playing, right? So how do we kind of visualize this information, right? So there are a couple of important commands that you can know, right? One is you can type in ROS topic list, and it will tell you all the list of those ROS topics that are currently being played here, right? So you saw this list before when I did the ROS bag info command. But if you want to just while you're playing the ROS bag, if you want to see what sort of information is available, you can type in ROS topic list, right, and it will give you all the list of information. And let's say you're interested in one particular topic. Let's say you're interested in the RGB topic. Okay, so by the way, so 60 seconds was over and the ROS bag has finished playing. Now the good thing is, since you're playing the ROS bag, you can do all sorts of things with it, right? For example, you can loop it so that it doesn't stop playing, right? So if I give the command -L, now it will just keep looping, right? And it won't stop. And for example, if you want to play it at half the speed, right, you can say -R, actually over here, ROS bag play -R for rate, and you can say, for example, if you want to run it at half the speed, you can say 0.5, and now it's running at half the speed, right? And if you want to speed it up, for example, and run it at say 10 times the speed, you'd say 10, and now it's running really fast, right? Okay, so that's kind of another advantage of having ROS bags. You can kind of manipulate time and how it's being played as well. So I'm just going to loop it, otherwise it'll have to keep stopping, and I'll have to play it again. So now it's just being looped. So let's say you're interested in one of these topics, say the RGB image, right? And you want to know what sort of topic this is. You can say ROS topic info, right? And if you copy paste this particular topic, this is the RGB topic, and if I paste it here, you can see it gives you information. Why isn't this looping? Yeah, sorry about that. Yeah, if you say ROS topic info and do this, and it'll tell you the type of messages, it'll tell you who's publishing it, if there are any subscribers at the current moment, and so on, right? So let's say you want to actually visualize this information, right? Then you can say ROS topic echo, right? So echo is you can kind of listen to that information and publish it and show it on your terminal, right? So if I say ROS topic echo and I show you and I press enter, you can see the information that's coming here, right? And this is basically the camera information, right? The images, which was kind of like a matrix of numbers, right? So now you're seeing that information being played out, right? So so that's a ROS topic echo command. By the way, you can write these commands down. So, and they are also covered in these tutorials here as well, right? So these are just standard commands that might be useful, right? So I covered ROS topic list, ROS topic echo, ROS topic information, and so on, right? But let's say, okay, so let's say it's an image topic and you kind of want to actually visualize it, like actually see the actual image rather than see the numbers, right? So ROS provides a couple of cool visualization tools. One of it is called RQT. So if I type in ROS run RQT image view, you'll be able to actually see all the camera information here. So for example, here we go, right? So this is the actual recording. This is, I think, in building 11 back in 2017. And see, as the ROS bag is playing, right? As the ROS bag is playing, this is the topic, camera RGB image raw topic, and the information that you saw in numbers here, this is what it actually looks like in an image, right? So you can see that it's being played in real time, right? So this topic, image raw, has these images as different messages, right? And if you want, you can subscribe to this topic, and then you can capture these images and process them any way you want, right? So this is the RGB image, and then you can see there's all sorts of other topics as well. Some of these you can't visualize in image view. You'll have to visualize it. There's a much more powerful visualization tool that allows you. So image view only allows you to visualize images, but if you have, say, point clouds and all sorts of stuff, there's another tool called RViz. So if you type in RViz, you'll get sort of this visualization tool, which will help you kind of visualize all sorts of stuff. So you can add a different topic here. So if you want, you can add, let's add the RGB image again. So if I add the RGB image, you see that RGB image is popping up here again at the bottom, right? But this is a Kinect and it's a depth camera, so it actually has depth information and point clouds. So if you want to visualize point clouds, you can do that as well. Actually, this doesn't have point cloud information. That's fine. So on week 5, when I play around with actual depth cameras, I can okay, it actually has point clouds. Sorry. Here we go. Right, so you can see this is actually the depth information, right, in 3D point clouds, right? So let me change the frame. So here you need to mention, as I mentioned before, there's different frames, right, of reference. So you can kind of look at it in different frames, right? So you can see this is what the RGB image looks like, and this is the depth information that is being published, right? So again, as I mentioned before, from ROS's perspective, it's as if I'm actually having a depth camera in my hand right now, and I'm back in 2017, and I'm actually moving this camera in real time, right? So this ROS, and all I'm actually doing is just playing this ROS back, which has a recording of all that information. So that covers important information about ROS bags, and I told you about different frames, right? So one last command that will help you kind of understand these different reference frames and coordinate frames in your system. So this is a single camera, but even in a single depth camera, you can have kind of multiple frames for the RGB image and the depth sensor, right? They could be situated at different physical locations on the sensor. So if I type in RQT TF, TF stands for transform. So if you type ROS run TF3, it will give you the transformation chain between all these different sensors, different frames. So there are 2 different frames here, and you can see the transform between them and how they're connected. But I'll show you a much more complicated transformation tree when we play around with actual sensors and robots. But usually what that transformation tree tells you is how these different frames of references are connected with each other physically, like what are the actual rotations and translation information with respect to each other, right? Anyway, just to that's sort of the end of today's lesson. So just to really quickly summarize and talk about a couple of more important things before we wrap up. I told you guys today about ROS, how it's a meta operating system that kind of acts on top of other operating systems. I told you about some important concepts in ROS, like nodes, topics, subscribers, publishers, different messages. And then I told you how you can record all this information in a ROS bag. And then I showed you how you can play that ROS bag in real time and then kind of access that information. And one final thing is that you can also load these ROS bags into MATLAB, and MATLAB has a toolbox that helps you load these information onto MATLAB and then kind of access them. So I kind of ran out of time to talk about that, but luckily in my tutorial playlist, if you look at tutorial question 3 and tutorial 3 question 1, actually if you look at tutorial 3 question 1, I run through how to load that ROS bag into MATLAB, right, and how to kind of access that information. So go ahead and watch this video if possible, and I'll anyway try to cover that aspect of ROS again, basically how to kind of take a ROS bag and load it onto MATLAB, so that we have all the information that we want actually on MATLAB, and then we can kind of process them and do all the stuff that we did in the last couple of classes, like convolutions and all sorts of stuff, right? So again, ROS can have different types of information as well. So today we just looked at camera images, but you can have all sorts of sensors, and it's not just sensor information. You can also have control information and tell different motors how to kind of function and so on, right? So that's just a very brief introduction to ROS with the example with the ROS bag. I hope you guys have a better understanding of what ROS is and can jump deeper into some of these tutorials. So from next week onwards, I would expect you to watch these videos and then come to class, and then we can discuss them, each of the questions more deeply. So I'll go question by question and see if any of you have any areas that need to be clarified. And I think this is the best way forward, because that way we get to cover all of these topics much more deeply than any of the other semesters, and also talk about practical things. Like today I talked about ROS and went into quite a bit of detail that I would normally not have time to, because I'm rushing to finish the tutorials, right? So just a quick reminder, this playlist is under the, I don't know why my browser keeps doing this, under the additional resources section on UTS Online. Okay, thanks a lot. I hope you learned something, and I hope the quiz went well for everyone, and I'll see all of you next week. Just look out for the poll that I'll send around tomorrow, probably tomorrow afternoon or tomorrow evening. Just please respond to the poll as quickly as possible so I can plan out our lab sessions. All right, have an awesome week, everyone, and thanks a lot for listening.